Hi everyone, my name is Muhammad Ammar, student at Civil Engineering Department, University of Baghdad, fourth stage, Group B. I'm here to introducing Composite Bridge Seminar. Group names Ali Hussein Hadi, Muhammad Ammar, Ali Mushtaq, Abdul Wahid Asad. Contents: Introduction, Advantage, Composite Action, Shear Connector, Design of Composite Bridge, Way of Composite Bridge Design, which involve simple beam bridge, over truss bridge, transoms on any type of bridge, decking, and summary. Introduction. Composite bridge means that the steel structure of a bridge is fixed to the concrete structure of the deck, so that the steel and concrete act together, so reducing deflection and increasing strength. A composite bridge is one whose decking system consists of concrete slab and which in conjunction with the steel girders resist moving loads on bridge. This type of bridge found to be economical for a span of 10 to 20 meter. Advantage. The first one is advantage for the given span and loading system. A smaller depth of beam can be used than for concrete beam solution, which leads to economies in the approach embankment. The second one is the cross-sectional area of the steel top flange can be reduced because the concrete can be considered as a part of it. Third one, transverse stiffening for the top compression flange of the steel beam can be reduced because the restraint against buckling is provided by the concrete deck. Composite action. The top flange of the steel girder as well as RC deck slab resist of compressive force, the bottom flange taking the tensile force as usual, as a result of having larger compression area. The steel girder possesses a higher load carrying capacity when the area of the bottom flange of the steel girder is increased, as shown in this equation. Composite bridge. Composite action is developed by the transfer of horizontal shear forces between the concrete deck and the steel via shear studs, which are welded to the steel girder. It's the best interest of designer to increase the section modulus as much as possible. Composite sections provide substantial section modulus with minimum material, and it's here that the principal advantage of composite action comes into play. Shear connector. Shear connector are part of parcel of composite deck system. The need for shear connectors can be understood by considering the interaction between the slab and the steel beams. If the slab simply rests on the steel beam, a phenomena known as slippage occurs. To avoid slippage, it's necessary that both units behave like common units, and this can be achieved by shear connectors. It's generally a metal element of particular shape which extend vertically from the top flange of supporting beam and gets embedded into a slab. Depending upon the magnitude of shear force at the interface of the beam and the slab, a number of shear connectors can be placed along the length of the beam. There are other forms of shear connectors such as welding steel bars with hoops, perforated plates, welded T-shaped plates, and short length of channel. Although these connectors provided a higher longitudinal shear resistance per unit. For perforated plates and T-shaped plates, they each have to be welded manually and consequently are more expensive. Design of composite bridge. Analysis of deck slab, dead load, live load, bending moment. Design of deck slab. Analysis of girder, calculate bending moment in main and cross girders, design of girders, flange, web, connections between flange and web, stiffener, connections between stiffener and web, design of shear connector. Way of composite bridge design. Composite bridge design can be used in the following ways. The first one is simple beam bridge on short spans, a meter, 10, 15, and then more expensively up to 24 meter. Bridge can be made from a number of beams under a road highway straight across the gap. The bridge benefit of the most from composite action, as shown in this figure. The second one is over truss bridge. These are similar to the simple bridge, but for longer span, from say 18 up to approximately 100 meter. This deck is still on the top of the steel structure, so it goes into compression when deflected, as shown in this figure. And the third one is transpose on any type of bridge. Transpose goes from side to side across a bridge, and carry the deck leads to a stronger steel frames on either side. This is usually on top, open top through truss bridge, or closed top through truss bridge, as shown in this figure. The fourth one is decking. In normal steel building, the concrete can act together with the steel decking. The steel decking taking the place of a regular steel reinforcing parts within the concrete. However, in a bridge, the underside of decking is liable to corrode over time, so it's not counted as a part of reinforcement. It's just used as a lost formwork, as shown in this figure. Summary: steel concrete composite bridge provide an efficient and cost-effective from a bridge construction by utilizing the tensile strength of steel in the main girder and the compression strength of the concrete in the slab. The bending resistance of the combined material is greatly increased, and larger span are made possible. Thank you for listening.